Hello, this is Mario from ODEON. In this video, we will show ODEON's measurement system, which is included in all editions of ODEON. ODEON's measurement system will allow you to measure room acoustic parameters in a real room, such as reverberation time, early decay time, and clarity. And with proper calibration, you can measure strength G, STI, and lateral energy fraction. You can also get the frequency response, for example, for a loudspeaker system in a room, as well as more advanced measurements like Kepstrom or spectrograms. ODEON's measurement system is based on the sine sweep method, which is superior than other methods at suppressing background noise and getting clean results. We have a video on the sine sweep method itself and why it is superior to other methods. Before we show the measurement system, we will show what is needed in order to make measurements with ODEON. ODEON sends the sine sweep to a loudspeaker, so first of all you need a sound card. For example, the internal sound card in the computer, which is where the mini jack output for speakers is located. Though you can also use an external sound card. This is connected to a loudspeaker, or multiple if you're testing the loudspeaker setup in a concert hall, railway station, or similar. For most room acoustic measurements, you need an omnidirectional loudspeaker, meaning a speaker that emits sound in all directions more or less evenly. Here, we are using our very own ODEON Omni, which we will talk about a bit more later in this video. The sine sweep will be emitted in the room for which you want to measure the acoustics, and the resulting sound will be picked up by the microphone. For most cases, here you will need an omnidirectional measurement microphone to get the acoustics of the whole room rather than from a specific direction. The microphone sends the signal back to the computer, either directly through USB, an external sound card, or the internal sound card, again, the latter being the mini jack input. We would recommend direct USB or an external sound card for less background noise. In summary, first, you need a loudspeaker that fits the purpose, which in most cases, that would be an omnidirectional speaker. But if you want to measure a PA system in the room, then you use that. Next, you will need an appropriate microphone. In most cases, that would be an omnidirectional measurement microphone. You can use an external sound card depending on the speaker and microphone used. Finally, you need any edition of ODEON and a laptop to run it. With everything plugged into the computer, you go to measure impulse response. Here, you select the output device, either the sound card or loudspeaker directly. And the input device, again the sound card or microphone directly. Here, you can access the window settings for your output and input devices. One thing you might want to check is if it is in exclusive mode. This allows ODEON to take full control of the audio, so that no sounds from other software interfere with the measurements. It may not always be possible, but ODEON can also measure without it enabled. You can also often set the sampling rate. If using exclusive mode, you can also control this inside ODEON. We suggest to choose 44 or 48 kHz, as higher values will limit the sweep length in ODEON. Some sound cards have audio enhancements, such as echo cancelling on microphones. When making measurements, all audio effects and enhancements should be off. Otherwise, the measured results will be wrong. If there's a boost level for your microphone in the window settings, it should not be changed during measurements. ODEON uses the sine sweep method, meaning that it will produce a sine wave signal that goes through all the frequencies of your measurement. The recording is then processed into an impulse response. There are some additional options to optimize your measurements for your specific purpose. The escape time is the time from when you press start until the actual start of the measurement. This is the time you can use to step away or leave the room. For most cases, however, it will not be necessary to leave the room entirely. The sweep duration is the duration of the sine wave signal. If you have issues with background noise, keep in mind that every doubling of sweep duration will lower the background noise by 3 dB, which is a property of the sine sweep method. Silence before is a more advanced setting for checking distortion, but for most users, the default setting works fine and can be left alone. The impulse response length / silence after is the time after the sweep that ODEON will still be recording, in order to make sure to record the full reverberation tail. Ideally, it should be slightly above the maximum expected reverberation time, but if you have no idea, it is always better to set it a bit too long. This is because the impulse response can be cropped later at any time, while a reverberation tail that got cut off cannot be fixed. Since ODEON still records for this amount of time right after the sweep is done, it is important to stay silent after the sweep for this duration. The advanced settings are optional, so for now we will perform a measurement, and we will talk about the advanced settings at the end of the video. At the top left, you have 3 buttons: Test, Start, and Stop. Down here, you have an input level meter and input and output level control sliders. The output is the level sent to the speaker. This should be set relatively high to have a good signal-to-noise ratio, but not so high that the loudspeaker produces distortion or suffers damage. And of course, be careful about not damaging your hearing if you're present in the room. Some sound cards do not react to changing the volume from within ODEON, so we recommend to check if moving the slider actually changes the level of the output. If it doesn't, then you should not move it during measurements. You can also test if the connection between ODEON and Windows works, by checking if adjusting the Windows volume also changes the output slider in ODEON. If it does, then you have the freedom to adjust the output during measurements, as ODEON will know the output level at different measurements and automatically compensate for the difference. The input level is the gain of the microphone signal, so it controls the amplification of the input by the sound card. The output level should always be your starting point, and then you set the input level so that you are well below clipping, but also not too low. The test button will just loop the sweep you have set up without recording. Then, the start button will perform the actual recording and measurement. Always make at least one preliminary measurement to see if you're able to derive all results, or if you need to change the measurement setup, such as changing the output level or increasing the sweep duration. Here, we see that the input level is too high, which causes clipping. If we're satisfied with the output level in the room, we only slightly lower the input slider and try again. After the escape time, the sweep, and the silence after, ODEON analyzes the results right away. Then you can manually choose where to save it. But if you will make many measurements and want them in a specific folder, you might want to change the default folder instead, so that you don't need to manually navigate to that folder for every measurement. To do that, we will first cancel, leave the Measure Impulse Response window, open Options, Program Setup, and choose the default path for saving measurements. Be aware that if you leave the Measure Impulse Response window without having made any measurements, the changes you made in the setup will not be saved. But if you did make a measurement, the settings will be preserved. We now make our measurement and save it. After the measurement, ODEON will open a window with a range of tab sheets with the results of the analysis. The first tab is the raw impulse response. The recording of the emitted sweep is processed into a raw impulse response, meaning the room's response to an impulse, which gives us a description of the acoustics of the room. You can approximate an impulse with a clap or by popping a balloon or paper bag. So, you can actually make more simple measurements by just recording any of these sounds in the room, then directly loading the recording by going to Load Impulse Response. We have a separate video for manually loading impulse responses, but using the sweep method will give better and more consistent results. You can cycle through different octave bands by using the up and down arrows. And you can also look at the broadband response. In all graphs, you can zoom in by holding left click and dragging towards the bottom right. You can reset the zoom by dragging towards the top left, and you can move the graph by holding right click. ODEON will automatically set the beginning of the impulse response, or onset time, and a truncation time at the end of the impulse response. While this typically works consistently, there may be times when the onset and truncation times are set incorrectly, especially in irregular impulse responses. So, you also have the option to manually set the onset and truncation times, which is also explained in our video on loading impulse responses. Having correct onset and truncation times is especially important for parameters that depend on time intervals, such as clarity and definition. This next tab shows the raw decay curve. This is the squared impulse response, and therefore shows energy instead of pressure. It gives a clear view of the decaying slope of the reverberation in the room, as well as the background noise floor. Again, you can change octave bands with the up and down arrows. The Decay Curve tab shows the integration of the raw decay curve, which is an even clearer view of the decay. If you go into the Energy Parameters tab, you can read the different acoustical parameters, like early decay time, T20, clarity, etc. You can copy the tables into an Excel sheet or similar for further analysis, and this is as easy as hitting Ctrl+C and Ctrl+V. You can visualize the parameters as bar graphs. You can cycle through parameters with the left and right arrows. Remember that you can copy-paste graphical results in ODEON just as with the tables. Here you can see the frequency response. This is very useful if you are measuring a PA system in a public space or concert hall, as it will show the frequency response of the combination of speakers and room. There is a number of errors you can get if you do not choose the right setup for your measurements. Parameters that could not be derived will be displayed as asterisks, which can be caused by different reasons. One could be an insufficient signal-to-noise ratio, which you can also see in the parameters as the decay range. To address this, you need to make the output level higher and/or make the sweep duration longer. If you decide to try increasing the output level, again, make sure that your output isn't so high that the loudspeaker produces distortion. You can also consider changing the sweep slope, as shown later in this video. For failures in reverberation times, it is also possible that the measurement time is too short to capture the full reverberation tail. For this, we mainly recommend to increase the silence after, though for low frequencies, increasing the sweep duration might also help. We will now go through the advanced settings. These are for further optimizing your measurements, but they are optional and require a higher level of technical knowledge, so you can ignore them if you're not interested or lack the needed understanding. The first advanced setting is the sweep slope, which determines how frequencies increase in the sweep and consequently the amount of energy in each octave band. For a pink slope, which is the default, the frequency increases exponentially, which results in more energy in the lower frequencies. However, keep in mind that higher octave bands have a wider frequency range, so a pink slope compensates for that and gives equal energy per octave band. If you change to a white slope, frequency will increase linearly, giving equal energy per individual frequency, but more energy in the higher octave bands. If you set this to manual, you can enter any decibel difference per octave band. You can also select the frequency range to measure. So, if you're not interested in some of the lowest or highest octave bands, you can use the same measurement time to have better measurements in your desired frequency range. In ODEON results, we use the octave bands from 63 Hz to 8 kHz. But if you follow the ISO 33821 or 33823, you can skip some of the octave bands. You can also choose your own range for specific measurements. However, keep in mind whether the loudspeaker you are using is actually able to produce a meaningful level in the range you choose. Especially, most omnidirectional sources will have a drop-off at low frequencies. If you are not sure of your source's frequency response, it might be safer to start at least in the 63 Hz octave band, or preferably at 125 Hz. Also, omnidirectional sources only remain omnidirectional up to a certain frequency, and can start to have lobes at very high frequencies. Often, the limit will be the 4 kHz octave band. So, if you measure above this, please evaluate whether your source can radiate uniformly at higher frequencies. Our new ODEON Omni performs quite well in both regards. First, it actually has a very good response at low frequencies. This is because it doesn't have the same problems with air volume compression as typical omnidirectional sources like dodecahedrons. And at the 8 kHz octave band, the directivity roughly stays in the ±2 dB range. You can learn more about ODEON Omni at odeon.dk/omni. The sweep spectrum correction is the option to let ODEON optimize your sweep in terms of signal-to-noise ratio at all octave bands. In a given room, some octave bands might be harder to measure than others, which can be due to varying absorption, frequency response of the loudspeaker, or background noise. Using a pilot measurement, ODEON can find the signal-to-noise ratio at each octave band. Then, taking this into account, ODEON creates a new sweep which redistributes the time spent in different octave bands in favor of the bands that have a low signal-to-noise ratio. So, this optimizes the signal-to-noise ratio across all bands, without having to further increase the output level or sweep duration. If this sets a really high level for the lowest octave bands, this might indicate that the source is very weak at that octave band. If so, you should consider if it is very important to get very accurate results at that octave band, or whether you can exclude it entirely instead. You can also set the values manually, but we do not recommend to set extreme values. The more time you spend on one octave band, the less you will have for the others. That covers the measurement system. As previously mentioned, we have another video explaining how to directly load impulse responses, but also how to derive statistics from multiple loaded measurements. We highly recommend to watch it. We hope you have found this video useful. Good luck!